In lecture number 29, we will discuss about sets. That is the definition of set, how we denote a set, and then we will discuss about some fundamental sets. Secondly, we will discuss about the methods of writing a set, that is how many methods are there to write a set and how can we write a set by using those particular methods. And lastly, we will discuss about how to recognize and perform different set operations on the given sets. So let's start today's lecture with the definition of sets. That is, first we are going to define the set and then we will discuss about the set notation. A set is a well-defined collection of distinct objects. Here are two words which are to be observed and discussed. First, it's well-defined collection. Well-defined collection means there must be some common property on the basis of which we keep those elements or we keep some elements in the form of a set. Just as set of even numbers, we collect the set of even number on the basis of a common property that they are all divisible by 2. So it is their well defined property according to which they are to be grouped together in the form of a single set. Then comes distinct objects. Distinct means no element of a set is to be repeated. Every element of a set is to be written only for once. Notations includes how we denote a set. The sets are denoted by the capital letters and the elements of the sets which are within the sets are represented by the small letters if they are in the form of alphabets. Next is the discussion about some important fundamental sets, out of which the first one is the basic and the most important set, that is the set of natural number. The set of natural number is denoted by n and it includes the elements from 1 and then it goes to so on. Now if we add 0 into the set of natural number, it becomes set of whole numbers. So the set of whole number is denoted by the capital letter W and it is equal to 0, 1, 2, 3, 4 and so on. Now if we include negative numbers in the set of whole numbers, it becomes set of all integers. That is, set of all integers is denoted by the capital letter Z and it is equal to 0, plus minus 1, plus minus 2, plus minus 3 and so on. So we can say that set of whole number is the subset of set of all integers and set of natural number is the subset of set of whole numbers. Similarly, we have set of all even integers. Now set of all even integers includes all those integers which are divisible by 2. Set of all even integers, it is denoted by the capital letter E and it includes 0, plus minus 2, plus minus 4, plus minus 6 up to so on. Since it includes the integers and you can easily observe over here that integers includes 0, positive and negative numbers. So here, since we are talking about the integers, even integers, so the negative and the positive, both even numbers are to be included in the set of even integers. Now The set of all odd integers is denoted by the capital letter O, and it is equal to all those integers which are not divisible by 2. The set includes all those integers which are not divisible by 2. So O is equal to the set which includes plus minus 1, plus minus 3 and plus minus 5. Then comes the set of prime numbers. You need to keep a difference between the set of odd integers and that of set of prime numbers. Set of odd integers includes all those numbers or integers which are not divisible by 2, and set of prime numbers includes those numbers which have at most two factors. One is the number itself and one is 1. Set of prime number is denoted by the capital letter P, and it is equal to 2, 3, 5, 7, 11, 13, 17 and so on. Then comes set of all rational numbers. Now we have already learnt about the set of all rational numbers in the junior classes. The numbers which can be written in the form of P by Q or which are in the fractional form are to be considered as rational numbers. So here we are going to represent it by Q, the capital letter Q, and it is equal to x such that x is equal to m by n. M by n means the numbers in the form of fraction or the lowest form of a fraction is to be considered as rational number, where m and n belongs to set of all integers. Then comes the set of irrational numbers. Set of irrational number is denoted by Q dash, and it can be defined as x such that x is not equal to m by n, means to say those numbers which cannot be written in the form of a fraction. Now this thing comes into our mind whenever we look at the definition of irrational number, that which are those numbers which cannot be written in the form of m by n. So these are those numbers which are square roots of non-squared numbers, means to say square roots of some prime numbers or square roots of non-squared numbers. That is, if we try to eliminate the square root of those numbers, we cannot do so. That is, the square root of 2 is square root 2, under root 3 is equal to under root 3. So the square root of these numbers cannot be vanished. So that is why these numbers are included in set of irrational numbers. Then comes the set of all real numbers. The set of all real number is the superset of all those set which we have just studied. So the set of real numbers include Q union Q dash, means to say the set of real number is the union of rational and irrational numbers. Firstly, we discussed about the set of natural number, that is the numbers which the set of natural numbers, that is the set which includes 1, 2, 3, 4 up to so on. Then we discussed about the set of whole number, that is if we include 0 in set of natural number, it becomes set of whole numbers. That now if we include negative integers or negative numbers in the set of whole numbers, it becomes set of all integers. Then we discuss set of rational numbers, that is if we include the fractions in the set of integers, it is considered as set of rational numbers. So basically set of rational numbers is the superset of all those sets which we studied, and set of irrational numbers includes some other numbers which we just discussed, which kind of number are those. Now set of real number is actually the union of set of rational numbers and irrational numbers. Then comes the methods of writing a set. So there are three main ways of writing a set. First one is tabular form or roster form. It is also called as listing method of writing a set. Secondly, written description or descriptive method of writing a set. Thirdly, set builder notation. Now we are going to discuss them one by one. Tabular form or roster method. In this method, we write a set by listing all its elements separated by the commas and enclosed within braces. It is the usual representation of a set, that is, if a set is represented as 1, 2, 3, that is, the numbers are written separately and their separation is done by the commas within and enclosed within the curly brackets or braces, then we can say that it is the tabular form or roster method of writing a set. The example of it is A is equal to 1, 2, 3, 4, and its examples can be considered as all those sets which we just studied in the fundamental sets. Now we will discuss about the written description or descriptive method of writing a set. The descriptive method of writing a set is simply to write a sentence or describe a sentence. That is, this way of to specify a set is to give a verbal description of its elements. That is, if we say that set of natural number, if we write it in the form of a sentence, that is SET, set of natural numbers, it means that it is the written description or descriptive method of writing a set. This description must allow a concise determination of which elements belong to the set and which elements do not. Means to say, if I am writing as set of even numbers, the word even clearly shows that it is including all those numbers which are divisible by 2. So if we are describing a set or writing a simple sentence related to the description of a set, that is set of even number or set of odd number or set of natural numbers, it should clearly specify which elements are and which elements are not included in it. Example is the set A is equal to A, E, I, O, U can be written in descriptive method as A is the set of all vowels in English alphabets. Now set builder notation is one of the very important method of writing a sets. It can also be considered as symbolic representation of a set. Specification of a set with the help of symbols, that is less than, greater than, less than or equal to, greater than or equal to, belongs to, and such that, is called set builder notation. This method is particularly used when a set cannot be written in roster method, when we have no idea about the starting and the ending number of a set. That is, if we specify a set of rational number, we do not exactly know from which number does it start. So here we do not have an idea of the starting and ending point of a set, so we cannot write the set in roster method or in listing method. So in that particular case, we make use of set builder notation to write a set. This method of writing a set describes the types of numbers within the set along with the upper and lower limit of a set. If the set is finite, then this method of writing a set also describes the upper and lower limit of a set. That is, the number from which it is starting and the number at which it is ending. Example is A is equal to x such that x belongs to the set of natural number and x is greater than or equal to 3. Now here it is giving us the starting point of the set, that is the set of natural number is here but it is starting from 3. That is the set of all x is from a set of natural number such that x is greater than or equal to 3. So this is how we write the set by using these three methods which we just discussed. But we should know which symbol do we use in set builder form and what is meant by this particular or that particular symbol which we are using to describe a set. Now the first symbol which we are going to study is this one. It is less than or equal to. Now it means that the numbers are which are there in the sets are less than some particular number, but they are also including that particular number. For example, a is equal to x such that x belongs to natural number and x is less than or equal to 3. Less than or equal to 3 means the set of natural numbers starting from 1 and goes till 3. So here less than or equal to 3 means 3 and the numbers and the natural numbers which are less than 3. The symbol number 2 to be discussed over here is greater than or equal to. B is equal to x such that x belongs to the set of whole numbers and x is greater than or equal to 5. It means to say that this set is including all those whole numbers which are equal to and greater than 5. Means to say it is starting from 5 and is going up to so on. Third symbol to be discussed over here is this one, which means belongs to or is a member of. If a is equal to 1, 2, 3, we can write that 3 belongs to a. And symbolically we write that 3 belongs to a by using this particular symbol. Number 4 is this one, which means that does not belong to or is not a member of. Now if we take a set a is equal to or b is equal to 1, 2, 3. Now the set a is equal to 1, 2, 3, it is not having 5 in it. So we can write symbolically it as 5 is not a member of a, or we can say that 5 does not belong to a. The symbol number 5 is such that. Such that means whenever we represent a set by a single letter, that is often we use x to represent a set. C is equal to x such that x is greater than 7. Means to say C is including those numbers which are greater than 7. 6 or. Or is often used to write a possibility, that is either x belong to a or x belong to b, and it is used to represent the union, that is a union b. This is AND operation of a set, and it is used to represent the intersection of two sets. Now recognizing operations on sets, union, intersection, such that up to so on. First of all, we are going to represent or we are going to discuss first set operation. The first one is union of a set. The union of two sets A and B, written as A union B, read as A union B, is the set consisting of all the elements which are either in A or in B or in both. Thus we write A union B as x such that x belongs to A or x belongs to B or x belongs to A and B both. Means to say, if A is empty and B is equal to 1, 2, 3, then obviously the union of A and B would be 1, 2, 3. Then here we can say that the union is merely from B. So in that particular possibility, we can write that if one set is empty and the other is including some elements, then definitely the union of those two sets will include the elements of that particular set which is not the empty one. So here we have the possibility that in the union we have element from A or B or from A and B both. For example, if A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6, 7, then we can write the union of A and B as 1, 2, 3, 4, 5, 6 and 7. We are uniting A and B and we are writing the elements of these two sets in the form of a single set. Now, intersection of sets. The intersection of two sets A and B written as A intersection B is the set consisting of all the common elements of A and B. In A intersection B, we write the sets from A and B but which are common in both the sets. And we write them symbolically as x such that x belongs to A and x belongs to B. And in symbols, we write them as A intersection B is equal to x such that x belongs to A, and then this particular symbol is used for AND. Now example is, if A is equal to A, B, C, D and B is equal to C, D, E, F, then A intersection B is equal to C and D. Since C and D are the common elements in A and B, so A intersection B is equal to C and D. Now we start exercise 5.1. Question number 1 is x is equal to 1, 4, 7, 9 and y is equal to 2, 4, 5, 9. Then find x union y. We are going to combine the elements of x and y and writing them in the form of a single set. So it is 1, 2, 4, 5, 7 and 9. Similarly, the intersection of these two sets should include their common element, and the common element of these two sets are 4 and 9. So x intersection y is equal to 4 and 9. Then comes the difference of sets. If A and B are two sets, then their difference A minus B or A slash B, actually this slash is representing the negative sign over here. That is the difference of two sets. A minus B is equal to x such that x belongs to A and x does not belong to B. It means that if we find the difference of the two sets, we write the non-common elements of the first set only. Means to say, we are going to write those elements in the difference of two sets which are in the first set only and not in the second set. For example, and similarly, if we are finding B minus A, then such that x belongs to B and x does not belong to A. Means to say, the set which is sequentially occurring first, the difference should belong to that particular set. For example, if A is equal to 1, 2, 3, 4 and B is equal to 4, 5, 6, 7, then A minus B is equal to 1, 2, 3, 4. Since A is written first, so we will consider those elements of A which are not in B. 1, 2, 3, 4 minus 4, 5, 6, 7. Here A has 1, 2 and 3 which are not in B. So the difference of these two sets is 1, 2 and 3. Since we are going to consider the leftover elements of the first set only, B minus A is equal to 4, 5, 6, 7 minus 1, 2, 3, 4. Here B is 4, 5, 6, 7 and A is 1, 2, 3, 4. But we are only considering those elements in the difference of two sets which belong to set A but are not there in set B whenever we do it for A minus B. But if we are doing it for B minus A, since B is at first and A is at second, so we are going to write all those elements of B which are not in A. So it is 5, 6, 7, which is the difference of B and A. The complement of a set is, if U is a universal set, the universal set is the set which is given to us, and it is the superset of the other two sets which will be given to us. If U is a universal set and A is a subset of U, then the complement of those elements of U which are not contained in A is denoted by A complement, or we write C in the superscript of the set notation. That is, A complement is equal to U minus A. The thing which you will have to keep in your mind is that whenever we are going to find out the complement of a set, it is to be subtracted from the universal set. So if we are going to find out A complement, then obviously it is equal to U minus A, and it can be defined in set builder form as X such that X belongs to the universal set, but it is not including the elements of A. Since we are going to find out the difference of U and A, and as we have already discussed in the section containing the difference of a set, that whenever we find out the difference of two sets, we write the elements of the first set, all those elements of first set which are not in the second set. Its example is, if U is equal to 1, 2, 3 up to 10 and A is equal to 2, 4, 6 and 8, then A complement is equal to U minus A. Since we have already discussed that if we are going to find out the complement of a set, it is to be subtracted from the universal set. The universal set is 1, 2, 3 up to 10 and A is 2, 4, 6 and 8. 1 is not in set A, so A complement is equal to 1, then 3, then 5, 7, 9 and 10. That is all those numbers which are not in set A. Now question number 4 of exercise 5.1 is, if U is equal to X such that X belongs to N and 3 is less than X. 3 is less than X means that set is not including 3, but all those elements which are greater than 3 up to 25 are to be included in it. Similarly, X is equal to X such that X is prime and it is between 8 and 25. That is, all the prime numbers between 8 and 25 are to be included in X. Similarly, Y is equal to X such that X belongs to W, that is set of whole numbers, and it is starting from 4 till 17. Find the value of X union Y complement. Since we have already discussed that to find out the complement of a set, we have to subtract it from the universal set. But here we have the two set operations. One is the union and the other one is the complement of the union of two sets. So since we are going to find out the complement of the union of two sets, and it is only possible if we have the union of X and Y. So we are going to find out the union of X and Y first, which is equal to 4, 5, 6, 7 up to 17 and 23. Now we are going to find out its complement, and we will have to find out the difference of the universal set and that of X union Y. So it will be equal to 4, 5, 6, 7 up to 25 minus 4, 5, 6, 7 up to 17 and 23. It is equal to 18, 19, 20, 21, 22, 24 and 25.